Can you guess what it is yet? If I move it out, can you tell? It's a lamp, a magical lamp, because when I touch the lamp it lights. Something on this channel that works for change, but it doesn't. So let me introduce you to the lamp that works but doesn't work. You see this lamp. When I touch the lamp, it should change in brightness each touch to 3, but indeed it does not. I touch it once, it turns on. I touch it again, it turns off. No, it should touch once, it becomes a little later. And then I touch it again, it gets lighter still. Then I touch it again till it's full brightness, but it does not do that. No, instead it just goes on and off. Because what has happened, you see, is the previous owner of said lamp has tried to fix it. And I have here the part they replaced. And you want to see what they done inside. Let me show you. Beneath the bottom of the lamp, it is removed. And under the lamp we have the new box they have put in and the wires that they have replaced. Now, forgive me for implying this, but this casing cannot be earthed because it is a touch lamp. If you earth the touch lamp, the casing of the touch lamp, then there's no signal for to register the touch. So the casing cannot be earthed. And bear in mind this is an unearthed casing. Would you really want your mains flapping around in the breeze like that? I'm not terribly convinced just having wire nuts and tape is the best way of doing it. I don't know what the best way to do it is yet, but that doesn't strike a lot of confidence in me for an object that's unearthed and conductive. So might need to rethink the insulation properties of these. Now, why is it not working? Good question, because if you look at the box they have got, this is the old box that they gave me. This is a new box. It is a new one. Come on, isn't LD600S. This is an LD600S. So I'd assume they are the same, but this one seems to be an on-off. This one seems to have a three-way switch, I guess. 3 brightness. So I'm assuming, because I've checked the wiring, they have actually wired it in properly. So I'm just assuming that this switch is different to that switch, and this switch is a 3-position switch, and that one isn't. So I'm going to see if I can fix this first. I'm going to see if I can take this apart, and I don't know, it's ultrasonically welded. So I can break that seal and then see what's gone wrong with this one. And if we can repair this one, that means we'll just swap that one out and be nice and easy fix. So let's crack this open first. Let's open it. That we are in like Flynn. Turn it over. Look at that. So, ooh, there's a funny mark on the board there. See, hold on to the light. You see that little line across there. Don't think that's the fault. I think that's probably just a bit of flux or something that's run over the board. I have a sneaky suspicion already, without even looking at this board. Can you tell what I'm looking at? Go on, give it a guess. Give it a guess. What do you reckon? What's going through my mind? It's the cap, isn't it? This is going to be a passive dropper. So you're going to have your... Which wire is which? Oh, I should take a note of that, shouldn't I? So it went in that way round. No, it went in that way round, didn't it? That way round. So live is brown. Blue is neutral. Okay, so live would be brown. Brown goes up into there. Goes through the fuse. Or resistor, which they're using as a fuse. Come on, get in focus! So there. And then straight to that capacitor pin. Where's that capacitor pin? Is that going to be? Capacitor pin is going to be up here. To here, yes. Yes. Yes, straight across to here. To here. Which then goes to... No. Another fat resistor. Down to here. There's stuff underneath this, isn't there? Yeah, there's gonna be stuff on. Yeah, there's something underneath the capacitor. That's probably a bridge rectifier and a diode. Oh, let me lift it. Ooh, there's lots of stuff under there. So I can't really see. but nothing looks blown or black or bruised or anything. There's no skid marks on the board. I strongly suspect, even without measuring things, that capacitor will have failed, because that's kind of what they do, because these rubber capacitors eventually they lose their capacitance over time, and what happens is the voltage, because these are a little power supply, the voltage on the output of the power supply, so to speak, drops, and therefore you get weird behavior with the circuitry. So that's what I reckon's happened. Now that is a Zoop. Is it? It is a. Does that give me a value? 145k. That doesn't make a lot of sense. Is there anything on top? No. Where's the capacitance value on it? It's a class X2 capacitor. 250 volt. So that's not 150 nano, is it? I don't know. Oh, there's a mark on there, but I don't think that's anything. And a blob. The blob, that's going to be the programming for the switching of different frequencies and stuff. Can you see underneath here? No, just resistors and some Zenas or diodes, whatever they are. They're the Zenas or diodes. D1, D2, D3. I reckon they're probably just normal diodes. Right. What value is that? 154. I'm not sure. Anyway, I'm going to desolder it and we're going to measure it. So this little capacitor is off the board, which you can't see the markings. So I think that 154k should be 154 nanofarads. We're measuring 35-ish nanofarads. So it's too low. So let's get another 150 nanofarad capacitor, whack it in there, and that'll either blow up or it'll be correct. 150 nano. And I haven't got a 150 nano, so I've got 300 nano, so I've got two in series here to lower the capacitance to 150, and obviously that won't fit on there, so we're just going to have to wire it in temporarily and just see if this actually fixes it. So the next section you're going to see some dodgy wiring, but that's okay, because we like a bit of dodgy wiring. Right, this doesn't look dodgy or sketchy at all, does it? So this is a test, obviously. So I've got my capacitors fit to the board via flying leads, and I've wired it all up temporarily. This is temporarily, people. Remember that. To the lamp, and there's the touch switch, which I'll just poke very gingerly like that, and then jump out of the way. So on a trip supply, let's power it up and see what happens. So it's on. We are drawing 1.6 watts so far. Doesn't turn on at all, does it? Yeah, so I don't think it is that capacitor. There is no power coming from it. Okay, that's enough dodginess. Let's turn it off and unplug it. Always unplug when you're working on main stuffs, because you only need to make a mistake once and you will not make a mistake again. So check my wiring here, make sure all my dodgy wiring is actually connected, which it is. So that's neutral, comes in to lamp red, and then black to black. So yeah, it's wired up properly. So it's not a Z capacitor. Annoying. Bit of a result. I've just gone around and basically reflowed all the joints because I was running out of ideas, and they all looked a little bit dry. Well, not dry, but you know, that lead-free stuff. So I put nice leaded solder on that. It's all powered up now, and watch, if I touch the end of this. Da, da, da. Oh, that's 2. 1, 2, 3. Off. So it's working. So what I'm going to do is put the original film cap back in, because that measures okay, and we'll see if it works. Then that original cap has been put back in, and it's still working 3 levels. So I say that's fixed. So it's just rubbish solder joints. So what I'll do now, I'll put it back in its little box. I'll make these cables good, and because this is terrible, and I don't like these original hat things, so I'll put them in properly. I'm tempted to actually change these wires as well, because they're aluminium core. I'll change them for copper wires, and we'll go from there. So put it back together again now. And there it is, all back together and running. There you go. So it's working. There you go. And if you turn it off, just go touch off. Right, so that's it. And hope you enjoyed that. If you didn't, then tough. But for now, see you later. Bye for now.